Welcome to this product demonstration, presented by the Vectorious team. Are you tired of searching through mountains of paper documents to find the information you need? Say hello to Vectorious, the ultimate solution to all your document management needs. Vectorious demonstrates how the use of vector databases and large language models can enhance data extraction and ad hoc searching within complex unstructured documents, like syndicated data agreements and resumes. Vectorious showcases the transformative potential of AI to streamline document processing. Whether you're grappling with intricate financial documents or curating resumes for your HR department, we demonstrate how vector databases and large language models can be harnessed to ensure precision and expedience. Bid farewell to the tedium of manual data entry and paperwork, and welcome a seamless experience that allows you to devote your energy to what truly matters. Now, I'll turn it over to today's speakers to show it all in action.
Okay, welcome to Vectorious. Today we're going to demonstrate to you guys how to use vector databases and LLMs for data extraction and question and answer support. To start off today, we're going to do a demonstration for you guys. Then we'll come back into the PowerPoint, go more in depth of what we're talking about, and then we'll do another demonstration for you guys. We'll have questions at the end. Okay, so here we have our application, Vectorious, which we chose it. We're using vector databases. And first we're going to upload a document. And our first document is going to be a syndicated debt agreement. Okay, if you don't know what this document is, it's a debt prospectus that discloses the terms and details of a loan being sought out by potential investors. Well, the funding comes from multiple sources, and they all come together in an agreement based on the terms of this document. As we can see, it's a pretty complex document. It has 54 pages, so if we had any interest going to this document, we'd have to go through and find all the information needed to see if this is something we would want to do. One of the things people look for in this document is something called an optional redemption clause. So if it was me and I needed to go and find out what the optional redemption clause of this document was, I just do Control F, search it. Which we can see it's still mentioned 27 times. So going through 27 times can still take a lot of effort to figure out that one simple thing. But if we were to go back to our application, we can see that the results are loaded, which the results are actually just a summary of that entire document. So we can see that here. And then if we scroll down, we see that the optional redemption clause is actually one of the things that we got out from that. So save us a bunch of time just doing that. And then once we have that document uploaded, we can actually ask questions for it. So if we wanted more information of that optional redemption clause, or if we didn't put it in there, it's pretty customizable what we have on that side. So we can add stuff, delete stuff, whatever we wanted to do. But just say we didn't have that, we could do, is there an optional redemption clause? What does it say? Yes, there's an optional redemption clause. The clause states that the issuer may redeem any or all of the 2024 fixed rate notes at their option at any time prior to July 16, 2024. And it goes into more information of what that optional redemption clause is. Another question that we can ask is, for someone like me, I actually know nothing about this document. So we could say, explain this document in simple terms. This document is a prospectus supplement for an offering of notes. The first part of the document describes the specific terms of the offering and the notes being offered. The second part is the accompanying prospectus, which provides more general information. Again, it goes on, gives more detail on that. So, if we were to go back to our PowerPoint, as I said, we use a vector database to do all of that. What you guys might be more familiar with is a traditional relational database, which uses rows and columns to organize our data. The rows represent a record and the columns represent a field on that record. An example would be Mary Brown, that's her student name, with a student ID of 456, major of finance, and an email of mbrown@university.ed. You can add more columns. Another example would probably be student username, add that there. We can save it to the database and then get that information anytime we want.
So a vector database works entirely differently. It doesn't have any rows and it doesn't have any columns. So instead, it's focused on the mathematical representation of the meaning of the data. So I've included an example here on the left of what that looks like. It looks like a list of numbers, and that's what we call a vector. And as far as translating the data into a vector, I have a small example here. So this is just a three-dimensional word vector, which for reference, the embedding model that we're using has 1,536 dimensions. But in this example, you can see on the top, we have femininity, youth, and royalty. And so when we take man, we get 0 for each of those. When we take woman, we get 1 for femininity, 0 for youth, and 0 for royalty. Boy gets 0 for femininity, 1 for youth, and 0 for royalty. And then at the very end, just for example, you can see femininity and youth actually get a 0.5 for monarch. So if this still seems abstract to you, that's okay. I have some puzzles here. So because of the linear nature of the embedding space, we actually get this kind of cool word algebra. And you can actually query a vector database in this way. So if I took king, but subtracted man and added woman, I would get queen. If I took Paris, but subtracted France and added Germany, I would get Berlin. You want to try this one? If I took cat, but subtracted kitten and added puppy, I would get
Dog.
Right? And winter minus cold plus hot.
Summer.
Yeah.
Those are cool.
So instead of searching the database by the word, we actually search by the meaning of that word. An example would be Netflix actually uses the vector database. When you watch a show and it gives you the suggested content, it will search that show you previously watched and get results back that were similar to that one. Next would be Spotify, the daily mixes that it creates for you or any playlist. It looks at songs that you previously listened to and gives you back songs similar to that. Next is Google, which we can actually see it's been around for a while. It's just getting a lot of attention right now because of how well it works with AI. And then finally, Amazon. If you were to go and buy an iPhone, it would most likely suggest an iPhone case.
So just to talk through the process flow a little bit, when we saw Madison do her demo, the first thing she did was upload that syndicated debt agreement. But because of the nature of a vector database, you can actually upload all kinds of data, audio, images, anything that's unstructured or doesn't have relationships that are easily defined will work really well with this. And there were 2 steps there. The first was that it chunked all the data into smaller pieces. And then each smaller piece, that's where we created the vector embeddings. So that's when the translation into the mathematical representation happens. And that is stored in the database. The next step is that she asked a question. When she did that, the question was also embedded. And then we looked in the database for similar things. So that is the similarity search part. Anything we found, we would return with the user's question. And that goes to the LLM. If you don't know what that is, it stands for large language model. You can think of it as being the engine under ChatGPT, but there's all different kinds of models. And finally, using that relevant data and the question, we get our answer returned. So we have another demo. This time I'm going to upload a different kind of document. So I'm going to select resumes, and I'm actually going to upload more than one. And I'll show you what these look like in a second. Okay. So the resumes are another good use case for this because they have similar content, but they all look a little bit different. People like to show their personality in these, and they're unstructured. So here is the first one I uploaded, and the second one, and here is the third one for a junior engineer. So now I will go back to the app. We can see that the results are loaded. So this time we decided to do a PDF just to show that you can do anything with the data extraction. And there's an option to print or download here. I'll download it so you can see what it looks like. So you can see we've pulled out the name, email, education, current job title, and then we generated a short summary for each resume. So because all three of those resumes are also in the vector database, we can also query against them. So I'll demonstrate that now. What tech skills does Jane Smith have? Jane Smith has proficiency in multiple programming languages and software development practices. She has leveraged online platforms such as Coursera, Udemy, and Free Code Camp to gain these skills. Do another one. What certifications does John Doe have? And we can see he has 2 certifications. I'll do one more. Here we can see it was not able to find any information in the document for this, so it just tells us that there was no information found. And we also have the power of the LLM here, so we could do something like who is the most experienced? Explain why in 3 sentences. And we can see it is telling us John Doe is the most experienced. He has over 5 years of experience as a software engineer, leading a team and developing a cloud-native application, and collaborating with product managers to refine software requirements. So an important thing to note here is experience is very data-based. If I was to ask who should be hired, something like that would introduce some bias into the LLM. For instance, a lot of the data on software engineers is probably male, so it might be more likely to pick John Doe. So a way around this would be completely defining your idea of who the perfect match is, and then you could use that as your data to make a decision. And I'll just do one more. I'm going to say write an email to Jane Smith explaining we'd like to interview her. And I'm going to ask it to include some details from her resume to personalize the email. So again, at this point, it's taking this and embedding it in the model, looking for relevant data in my database, and that's how it will formulate my response. Dear Jane Smith, I hope this email finds you well. My name is Reagan Barrington, and I'm reaching out to you on behalf of Kingsmen Software. We recently came across your impressive resume, and we are interested in interviewing you for a position at our company. We were particularly impressed by your self-taught education and your proficiency in multiple programming languages and software development practices. Your continuous efforts to update your knowledge with the latest industry trends and technologies demonstrate your dedication to staying at the forefront of the field. So we can see it did pull some details because we know that Jane Smith was self-taught.
So we just showed you guys 2 examples on how this can be used, but this can actually be used in any document-intensive process. Some other examples is equity and debt documents, commercial lending, mortgage processing, lease agreement, merchant agreements, commercial insurance, medical claims, and the hiring process. Pretty much any document that you could think of that you can extract data from, we could do.